Okay, number 70. Landscape architects wants to enclose a 3,000 square foot rectangular region in a botanical garden. She will use shrubs costing $45. So here's my rectangle. Shrubs costing 45 along three sides, and fencing costs $20 along the fourth side. Find the minimum total cost. Okay, so we want to find um, minimum cost C. Okay, so I need to write an equation that involves for C here, right? Well, I've got a fencing on one side. So this is my fencing. And that's going to cost $20 per foot. And on the other sides, it's going to cost $45 for a foot of shrubbery. Okay, and I'm going to go ahead and call this side X and this Y, because these two sides are the same, of course, and this one's different. So the cost is going to be 20y plus 45y plus 45x plus 45x, where x and y are the number, comma y equal number of feet, or just feet. X and y in feet. Okay, so I would like to find what is x or what is and y that maximize the cost. So if I want to find the derivative, I got to solve it for one or the other. So the question is, what's the relationship between x and y? Well, I know xy equals 3,000, so y equals 3,000 over x. So I can go ahead and do this. Cost is 65y plus 90x, which is 65 times 3,000 over x plus 90x. So that's my cost, and that's what I want to take the derivative of. So let's go ahead and just do this, make it maybe a little easier. 65 times 3,000, 195. Okay, so C prime would be negative 195,000 over x squared, because remember that's x to the negative 1, plus 90 equals 0 to find my critical points. So if I do this, 195 over x squared, then I know that x squared equals 195,000 over 90, which is not a very nice number. I'll leave it like that. And I get x would be plus or minus, but I only want the positive root of 195 over 90. So I've got that over here in my calculator. It ends up being 46.55 feet. So the question is that a max? I've got to verify that it's a maximum. Okay, so I'm going to come over here and put in. Now you have to recognize that this is now a rounded number. Okay, so if I pick a number less than it, I need to pick something. So I'm sure it's on the right side of the rounding, right? So pick on this side a very much smaller number, and this side a very much bigger number. So C prime. So number less than 46, like say 10, and I picked 10 because I'm looking over here going, oh look, I can divide by 10 really easily, or divide by 10 squared. So that's going to be a negative number, right? Isn't it? Is that right? Yep. So it's negative. The problem is we want a maximum. Oh, we want minimum total cost. Because I was hesitating there, so I'm going, wait a second, this is going to give me a minimum, and I was thinking we want a maximum. Okay, and C prime, number bigger than that, like say 100. So 100 squared is 1,000, so, or 10,000. So that's going to make this number less than 90. So to be positive. Okay, verify those, don't just assume it. Okay, in other words, negative 195 over 100 squared plus 90, okay, is positive. Okay, so therefore x equals 46.55 feet gives a minimum. So we want the dimensions. Oh, let's see, I know that y then is 3,000 divided by 46.55, which will give me 64.45. Okay, so if my rectangular region, to minimize the cost, it would be 46.55 by 64.545. Okay, so there's my dimensions to give me the minimum total cost. Okay, by 64.45. All right, there you have it. Shoot me an email if you need anything else on any of these.